All right, so we have a diagram here showing our function f of x, and for part A, we're asked to find, on the same axis, we're going to sketch the graph of y, which is just a transformation of f of x. Now we can see that we have three separate transformations, and we can look at this a couple different ways, actually. So the first way, because we have these sort of linear segments here, I just wrote down the endpoints of each of those linear segments, and I'm just going to think about translating those, or transforming those rather, okay, one bit at a time. So I have all of my endpoints here. All right, now we have, first thing we're going to do is we're going to multiply our x, right, by a scale factor of 2. Okay, so that's our first transformation, x multiplied by a scale factor of 2. Second thing we're going to do is we're going to shift left 1 unit, right? And then third thing we're going to do is shift up 5 units. Okay, so those three things are what we're going to do, and we're going to make sure we do them in that order. Okay, because I have f of 1/2 x plus 1 in parentheses and then plus 5. Okay, so first thing, scale factor of times 2 for our x values. So our -4 becomes -8, and then we're not doing anything to our y yet. Our 2 becomes 4. Again, we're not doing anything to our y. And then our 4 becomes 8, and we're not doing anything to our y. So this is going to be transformation number 1. Okay, and then we also have, for transformation number 2, we're going to shift everything left 1 unit. So my -8 becomes -9. Again, not doing anything to my y yet. My 4 becomes a 3, and my 8 becomes a 7. Okay, not doing anything to our y. And then lastly, let's see how I can do this here. We're going down. This is our third transformation. Now we're shifting up 5 units. So that is only going to affect my y values. So all of my x values will remain the same. Okay, and then our -4 will become positive 1. Our 4 will become a a 9, and our -2 will become a 3. All right, very good. So these are going to be our endpoints here. So this is going to be -9, 1, 3, 9, and 7, 3. Okay, so our function will look something like that. Okay, now we could also do this another way. So that's going to be sort of approach number 1. I can also think of this as f of 1/2 x. I can distribute that 1/2, right, plus 1/2. Now when we do it this way, it's just going to flip our first two transformations. So first thing we're going to do at this point is we're going to shift left by 1/2 unit. Then we're going to multiply x by a scale factor of 2. Then from there we would shift up, and that doesn't change our shifting up of 5 units. So again, if we started off with -4, -4, and 2, 4, and 4, -2. Okay, so our first transformation is going to make our -4 a -4.5. Okay, our positive 2 becomes 1.5, and our 4 becomes a 3.5. And we're not changing our y values just yet. And to represent our shift, or our scale factor multiplied by a scale factor of 2, so that -4.5 becomes -9. -9, -4. We have 3, 4, and 7, -2. Okay, so that is what we end up with after the second transformation. And then the third one, we're going to shift up, and we'll end up with the same values that we have with the first approach. So that -4 becomes a 1. Okay, the 4 becomes a 9. And we end up with 7, 3. Okay, so that is for part A, all that you would need to do. And now looking on to part B. Okay, if you're unsure about what this transformation would look like, the absolute value, f of absolute value of x, you can always just go ahead and write out a table. So if we started with a table of x and y values, and we'll say -2, -1, 0, 1, and 2. All right, so if we just start off with 0, so I'm going to plug in 0, and what's the absolute value of 0 is just 0, right? So I end up at this same point here. Okay, so it's like I plugged in 0, right? And that gives me a value of, if you do the numbers, that gives you a value of 4/3, okay? If we plug in 1, okay, +1, that gives me a value of 8/3, okay? And if I plug in 2, then we get 4. Now, if we go and take a look at the negative side, if I plug in -1, the absolute value of -1 is +1. So I still moved this way in the negative x direction 1 unit. However, okay, I have the same output as if I had plugged in +1, which we said was 8/3. Okay, so I end up with a point right there, okay, at 8/3. Same with -2, okay, I move over -2 units to I move 2 units to the negative x direction. But it's like I plugged in +2 because the absolute value of -2 is 2. Okay, so I end up with the same output for -2 that I had for +2. All right, so that's going to be -2 and 4. So what you end up getting is this sort of, be careful, it's not really a reflection in the y-axis, okay, but it is sort of this graph where anything that is to the left of your y-axis, so this whole part of f of x, right, that kind of goes away, and what you get is this mirroring of whatever you have in the positive x direction. Okay, so you end up with this sort of M shape here, and it's asking, okay, if we were to set f of absolute value of x equal to k, okay, well, that's saying our output y is equal to k is going to have exactly 2 solutions. So we need to find values for k. So y equals k is some horizontal line, right? So if I were to set k equal to, say, 3, we set k equal to 3, we get a line that looks like that, right? How many solutions does that have? That has 1, 2, 3, 4 solutions, right? That has 4 solutions. So that is not going to work for us, okay? However, if I make k equal to 4, that is going to be this horizontal line here, right? And we can see that it's just going to hit those 2 peaks, right, 2 times. So I have 2 solutions there, right? So k equals 4 is going to be in my solution set. However, if we come down here, and this is why it was important to find our y-intercept, okay? If I set k is equal to 4/3, well, when k is equal to 4/3, I actually have 3 solutions, right? However, if I just nudge k down a little bit, right, then I end up with 2 solutions. So in between, okay, -2 and 4/3, right, can we see that everything in this sort of shaded region here is going to only intersect my graph 2 times. So I'm just going to have 2 solutions. Okay, so between -2, because that is where my graph stops, right, and 4/3, okay, k can be somewhere in between those 2. Now, if k is equal to -2, we still end up with 2 solutions. So I can say -2 is less than or equal to k, all right? However, be careful with this final inequality because, like we said, if k is equal to 4/3, we have 3 solutions here. So we do not want to say k is less than or equal to 4/3, just less than 4/3.